Hello students, today we're looking at lesson 6.3. This is our last lesson in chapter 6. It's a short chapter. So looking at scatter plots, continuing with scatter plots, we know that when a pattern or relationship or trend exists between our two variables, we say that a correlation, remember that word, exists between the variables. Sometimes you'll notice that the points form more of a curve than a straight line, and that's okay. I'm going to show you some examples here where we can see that a curve would better represent the data or the points in the scatter plot than a line. So looking at this first graph, all these points here are provided. I could draw a straight line running right through these points. Just draw one in for you, if it allows me to. I could draw a straight line, and it's not bad. Okay, the line does pass through a few points. I've balanced the other points. But look at what happens when I instead use a curve. If I can move this back on. When I use a curve, you can see that it touches a lot more of the points and it better balances the points. So in this example here, in fact, a curve would be a much better choice when I'm trying to show the correlation between the two variables here. When I draw curves, what's important to note is that it has to be a single smooth motion, just like this. Okay, so almost like a line, just slightly curved. I'm not going to connect my points with a zigzagged curve like that. Okay, that's not correct. We're going to use a single motion, just like a straight line, and just slightly bend our line. Okay, that's how we draw curves of best fit. Looking at our second example here, again, I could draw a line, but in fact, these points seem to form a curve, a smooth curve, more so than a line. Example 2. I want you to take this information in this table and I want you to plot the data on a scatter plot. So recall what I said, my first column is always going to be X, my second one is always going to be Y. Okay, whether we run horizontally or vertically, it doesn't make a difference. So X will be time in minutes, Y will be number of sit-ups completed. So I know that for my X-axis, I have to plot all these points here. So I'm going to need to show 0.5 to 4. And for my y-axis, I'm going to need to show the values 17 through 91. So I need to think about an appropriate scale. Okay, so on my scatter plot, I've got time as my x-axis, going up by increments of 0.5. Y-axis is number of sit-ups, choosing increments of 10. And there should be a title. Don't know what happened to my title. Let me add that in right now. I'm going to call it number of sit-ups completed over time. Okay. Let's see if I can make this a bit smaller. It's going to cooperate. Okay, so there's my title. I'm not cooperating today. There we go. Okay, so I've got a title. I've labeled my axes. I've plotted my points. Okay, so my first point, 0.517. My second point has coordinates 133, etc. I plot all my points on the scatter plot, and I notice that my points form a nice curve. Do you see that? A curve is much more appropriate here than a straight line. Okay. If I were to describe this relationship, so I'm going to use the same knowledge base that I have for linear relationships. I can see my curve is curving upwards to the right, so I'm going to say that that's positive, just like I would for a straight line. Okay, my points are very close to the line, so I'm going to say that this is positive and very strong, very, very strong correlation. And if I describe the relationship, as time increases, the number of sit-ups that I have completed also increase. Okay, more time that goes on, more sit-ups are completed. D, use your curve of best fit to estimate the number of sit-ups completed after 7 minutes. So 7 minutes, what happens? Look at my graph, it stops at 5. I'm going to have to use extrapolation. Remember that word? I extend my graph, I draw a vertical line up, and I read across, and it would be off this grid here. Would probably be, once I've extended it, I'm going to say about 110. Okay, and that's what I've written here, approximately 110. So this equal sign that's been altered so they're not straight lines, they're squiggly lines. That's the symbol for approximately, for those of you that haven't seen that before, but I think we have used that a few times in our class. Okay, so for homework, looking at curves of best fit versus lines of best fit, I'd like you to look at page 349, numbers 1 to 8. Again, this is the last lesson in chapter 6. There will be a short assignment following. Okay, have a good day, ladies and gentlemen. Please do reach out if you have any questions. Thank you. Bye-bye.